Hello and welcome to Learning from Failure. My name is Zachary Segay, and
My name is William Hearn, and I am the CS4 on the Cloud Native team at Statistics Canada, working as a cloud architect with a focus on using open source cloud native technologies to try to improve how governments deliver services to Canadians.
a lot of our work is available on the StatCan GitHub organization. So failures will happen, but we can still learn from them. So we can mitigate them by applying proper defenses. We can learn from them and prevent them from happening again. We can improve our troubleshooting and debugging skills to quickly resolve any type of issue that we encounter. The first type of failure that we're going to talk about today is system failure. So when the system fails us. Generally, system failure is caused usually between the integration and dependencies between components. Sometimes we got version incompatibilities, you've got software bugs, you've got configuration errors, changes in your platform that happen under the hood, especially running in the cloud where we're relying on Microsoft or Amazon or Google or all the other cloud providers. On the right on this slide, there's a whole series of tools that we have in our environment. All the boxes on the left and the top box are our main ones. The other two boxes kind of touch more on our data science platform that we've been building on top of Kubernetes, but we've got things like the Open Policy Agent for policies. You've got Istio for your service mesh, Vault for secrets, Terraform, Helm for your infrastructure. You've got your Docker containers and the Docker runtime. We've got Elastic Fluentd for logging, kubectl for cost tracking, Prometheus and Grafana for metrics monitoring. So there's a lot of possibility for errors to happen. And the main system, Kubernetes itself, is a very large system. It's always under development. There's always new features, always new bugs, especially when you start talking about the integration with the cloud provider. So kind of one of our stories of really probably the biggest failure we've ever encountered in our system is late last year, we all of a sudden started getting a bunch of errors related to our disk mounting. So disk would be attached to VMs that no longer exist, or disk would be attached to the wrong VM. And Kubernetes would try to correct it and the situation would get worse, or Kubernetes wouldn't be able to correct it because it thinks it's attached to the right VM. Azure says it's attached to a different VM. It was a very weird situation of events, and it was also compounded by other errors related to scale sets in Kubernetes in Azure. So that kind of like all happened at once. We saw the error almost daily in the development environment, and very rarely, but it did happen in our test environment. Fortunately, it did not happen in our production environment. It seemed to correlate with the application deployment, but in particular, the application deployments from one of our specific app teams. We kind of came up eventually with some manual workarounds, but we really spent a large amount of our days applying those workarounds and fixing our clusters. So we opened a support request with Azure about this, especially since Kubernetes would claim to do the actions, but they wouldn't reflect in the Azure portal. It took a long time to get the right support team at Microsoft engaged. We weren't using the managed Kubernetes offering for these environments. So getting the official Kubernetes team was unable to support us. The other teams were doing their best. Eventually, we also recreated this issue in our managed Kubernetes clusters, as well as we noticed an increased number of cases on the AKS support queue matching this error. Eventually, the Kubernetes team did engage with us. We were able to talk to them directly, get their help. They engaged them, the virtual machine scale set team, and we really deep dived into this issue. So over a couple of weeks, we spent a lot of time email correspondence, troubleshooting sessions where we'd be on the phone, screen sharing sessions, going into the logs. Eventually, Microsoft did identify the root cause. So really, it was a race condition and a caching issue inside of the Kubernetes Azure Cloud Controller. So the first issue was it didn't maintain the state of a pending unmount. So what would happen is the next request, when it did a different disk operation, it would have that disk as being attached to the virtual machine. And so that resulted in the Azure Cloud reattaching it. And based on the right timing, you could end up with a disk that no longer exists attached to a VM. But there was also a caching issue, which resulted in some API issues because of cache issues or inconsistencies between what Azure was reporting and what Kubernetes was reporting. We managed to see the pending pull requests in the Kubernetes repository. So we custom built the controller manager component of Kubernetes with the fixes for that. We did confirm with Microsoft, who were unsure whether they should send us the pending fixes or not. We kind of took them on our own, but we confirmed that it did in fact fix the issue we were having. The biggest thing that we learned from this is really it demonstrated our ability to work with the community, especially the Kubernetes community and the cloud provider, to really deep dive into this issue. But it also highlights the power of open source. So we didn't have to wait for the vendor to come back to us and be like, here's a released version. We saw the in-progress code, and even though it wasn't perfect, we decided to take the risk and run it. So we were able to bring those patches down and apply it to our code and compile the controller manager. Sometimes we saw other failures in our environment. So the system fails, a node runs out of resources. So we're really working on trying to use the Kubernetes resource requirements to help the scheduler in assigning tasks, but also to allow Kubernetes to terminate pods that are violating their resource requests. So if there's a memory leak in an application, for example, it won't take down an entire node. We're also working on improving our monitoring and alerting for node resources. So in particular, memory and disk usage. I think those are really the two that we hit the most. And especially memory, when we get an out of memory situation and the Linux kernel starts turning applications, it usually results in the node going offline. We also have an issue where our cluster policy enforcement engine, so Gatekeeper, crashes. And then when it tries to restart itself, it fails because it then needs to make a request to itself to verify its permissions. This is really a bug in Gatekeeper. There is an open GitHub issue on this, but we do have manual workarounds for starting out, but it's just being aware of the shortcomings of the applications in your system. That's kind of the system itself. From there, there's also external changes or failures that can impact us. So like our system doesn't live alone. We rely on other cloud services to function. We rely on our networking configuration. We rely on our firewalls. There are cloud policies that are applied to our tenant that can impact our environment. I mean, there's the cloud vendor itself. There are, certificates that can expire or secrets that can expire and prevent communication with other systems. The authentication system can go down, or policy changes in the authentication system can impact availability of our system. Kind of some of the more common errors we've seen is DNS failures, so that the cloud DNS service stops responding to us, or the on-prem DNS server stop responding to us. There can be firewall policies that have changed and now our traffic's being blocked. So either traffic trying to reach the cluster or the cluster trying to reach other environments. We've had a lot of issues with our firewall intercepting our SSL traffic. So sometimes it would replace the certificate with its own, or it would just cause the SSL connection handshake to hang. So these are bugs that we're working with our firewall team on, and I believe they have vendor support tickets open with those as well. So it's just stuff to be aware of. We've also seen things where network routing has changed, so we can't reach certain services anymore. Or we can have Azure policies that are applied to our VMs that re-enable certain functionality that we have disabled. Like, for example, the managed identity. We use a named identity versus a system identity. And unfortunately, if the system identity gets enabled on our master servers, we are no longer able to decode our cluster secrets because the system identity doesn't have the right permissions to access the key vault. So it's being aware of those and understanding how Kubernetes interfaces with all of these systems. How do we prevent issues? I mean, this is an ongoing thing within our cloud team as a whole, but really we should have a change management process that really disseminates these upcoming changes to the teams. And if the team as a whole has an understanding of the impacts of their changes on other systems, we can plan those ahead of time. But also gives us a place to start looking if something breaks after we make the change. Finding the problem. The first thing is it's stay calm. I mean, it's easier to debug when you have a clear mind than when you're panicking. No matter how big the error is, or how big the failure is, or how many things are down, or how impactful it is, if you stay calm, you'll find the problem a lot faster. If you approach it methodologically, you'll be fine. So how do you find the root cause? So really, if you understand how your system works, and basically how it interacts with the different components, with the external systems, and really how to verify those interactions, you can really pinpoint down the issue fairly quickly. So kind of the first place we'll look is usually some logs. We'll use some of our debugging tools. So we can use Dig to debug some DNS issues, Telnet and Netcat to attempt to connect to remote services and really find out if the problems with the remote service, if is it with the network. We can TCP dump and really see kind of the traffic in real time. If we're having SSL issues, the OpenSSL command line can really help us debug those issues. So that there's plenty of tools out there to help debug an issue. You can get kernel level tools like strace and LSOF to really kind of try and see what the application is doing as well. For any of our custom components, and in particular, especially our gatekeeper policies that are in effect in the clusters, we really try to provide back useful error messages that really help guide either users or ourselves towards the issue and or the solution. And then finally, depending on the issue, you might have to work with the community. So work through GitHub issues. You can look through the code. I mean, all of these components are open source. So we spend a lot of time sometimes looking at the code and fixing the code ourselves. And then we'll submit those patches back up to those services. There are community Slack channels. So Kubernetes is a very large Slack channel, many thousands of people in there. We've gotten support there. Many of the other tools and services we use also have Slack channels. So those are great resources to reach out to. As you get more into the open source community, if you really try to be part of the community, you're gonna make personal connections. You might make those just by working with someone on an issue, talking with someone on Slack, or even attending conferences. Back at last fall, Will and I both got the opportunity to attend KubeCon, and we really met some of the people behind a lot of the tools we use and really helped ensure that we're going down the right road with our system, with our implementations, with how we're trying to use the different technologies. So those have been a huge bonus for us. A lot of projects also hold office hours, so that can also be very useful.
Under most situations, it is not advisable to rewrite a component of your system, and especially writing it in a different language. Unfortunately, there are the rare instances where this is the only way to resolve this issue. In our data analytics platform, the Jupyter Notebooks API was not functioning correctly from the web portal. Frequent requests to the API would just hang. After much debugging and attempting fixes, we determined the issue to be deep in the Kubernetes Python client. Rather than thread down that path, we decided this time to experiment with replacing the API with a Golang version, Golang being the language that Kubernetes is written in. We even went beyond just re-implementing it, but also adding additional layers of caching to decrease the response time, and we succeeded in reducing it by approximately 50%.
And then there's the human errors. Unfortunately, we always make mistakes. We can put a lot in place to try and prevent it, but it happens. Kind of the most common human error that we've come across in our environment is generally when an administrator, more than an app team, unintentionally deletes the wrong thing. So we have at least two major instances of this happening. The first one, and it's a very easy mistake to make. You miss the C when you're typing and you delete all the persistent volumes across the cluster, which are not namespaced, versus all of the claims or persistent volume claims in one namespace. For those who aren't super familiar with Kubernetes, a persistent volume claim is a request for storage matching a certain specification, which then a persistent volume is created and mapped to that PVC. Kubernetes command line does not give you a warning if you try and delete non-namespaced objects while passing a namespace parameter. So if you give it delete -- all, it will delete them all across the entire cluster. Very similarly, you're trying to be a bit more safe. You're like, I'm going to check the output before I run the delete. So, you run your kubectl get. Unfortunately, you need to grab something because you don't have enough. You don't have just one label you can filter on. You're like, great, looks great. You run the next command, you pipe it over to kubectl delete, except you accidentally remove the grep. It deletes everything. These are two kind of delete issues that have happened. And it happens. So kind of what's gone right with some of these. I mean, with the data one, I mean, Kubernetes prevented a catastrophic loss of data. So there are protections in Kubernetes. So the delete hooks actually prevented the removal of the persistent volumes that were still mapped to persistent volume claims. Similarly, if you were deleting a persistent volume claim, it will not delete while it's still attached to a running pod. Because we didn't know the impact and we didn't know that this protection existed, we also added an infrastructure level lock to those resources. So we went to the resource group in Azure where our cluster is running, and we applied a delete lock. So even if it got past all of the protections in Kubernetes, there was still another layer of protection. While we investigated too, thankfully we had enabled audit logs, so we were able to download the audit logs and go find out who run it. Now, thankfully, we didn't actually need to rely on those. We did identify with our users or our administrators who had accidentally ran the wrong command. And you know what? It happens. We didn't obviously get mad. We didn't do anything. We stayed calm. We went, okay, well, we learned a lesson. So we first went, how can we fix this? So we could have left it as it was, but it's not a very comforting feeling to see all of your persistent values stuck in a terminating state. And in Kubernetes, you can't cancel a termination. So what we did is we wrote a Kubernetes script that actually changed the retain status of those persistent volumes to keep the actual Azure disk around. We deleted the persistent volume and recreated it and remapped it to the PVC, and then reset the retain policy back. So basically, all we did was remove kind of the metadata mapping, but we didn't remove the disk itself. So all of our disks are back in a good state. The next thing that we talked about is how can we prevent this issue from happening again? So there was a few things that we came up with. So that's, we can run the commands with the dry run flag. So the dry run flag will actually run it locally and not run it against the cluster right away. So you can verify first that it actually is deleting what you think it's going to delete. Maybe if you're doing really sensitive operations, pair programming or getting a second opinion before you execute it is worthwhile. And then finally, and something we're working towards, but there's other changes outside of our environments that are needed. It's not using your admin credentials for non-admin tasks. And this also stems from the ITSG 33 controls. So AC6 talks about the principles of least privilege. So on a day-to-day operation, we don't need global admin privileges across our clusters. Especially when I think of like our data analytics environment, where we're both users and administrators. We should have two separate accounts for that, and we're working on bringing that to our whole team to prevent this kind of thing from happening again. I'd like to say we're going to prevent it from always happening again, but it's not going to. I mean, thankfully, Kubernetes has protections. There are other protections to prevent our users from doing malicious changes, or not even malicious, but accidental changes to their apps and environments. There's a very strict role-based access control system. We have a set of additional policies on top of that, powered by Gatekeeper, that really help control the environment and prevent those accidental mistakes. There will be times where we might have to disable policy to make a change, but it's better to be safe than regret it. So thank you. That's really kind of a very brief highlight. It's a couple of the major failures we've had and kind of what we've learned and where we're going with it.
The most important thing to remember is that failure will happen. It cannot be 100% prevented. When failure does happen, remember to stay calm. Identify the root cause of the issue and not just the symptoms of it. Make note of anything mitigating or aggravating circumstances about the failure. Did something prevent the failure from being worse? Did anything make the failure worse? Next, note your response to the issue. What actions processes worked? Which ones didn't work and why? And finally, identify any action items that can prevent the issue from happening again. Identify any process improvements that you can use to improve your response, and make sure to action them.
If you want to know more about what we're doing, there are two other Stratosphere 2020 presentations from StatCan. Session 6B was the DAS, Data Analytics as a Service using CNCF technologies. That's the technical deep dive into the data analytics platform. And then there's also session 7B, which is Advanced Analytics Workspace. So rapidly deploying and data science capabilities in the cloud. And that talks about it more overall and from kind of more the user perspective. There's also a presentation from last year's Stratosphere conference. So it was Kubernetes and Containers Ecosystem, CNCF, Security with Istio Service Mesh, Knative Serviceless, and the Open Policy Agent. And, really ask us. We're really happy to always be sharing about our work. You can find it all on GitHub as well at github.com/statcan. We're always happy to meet with you and talk about it and share our experiences. Our contact information is available on this slide. And if you have any questions, we're happy to answer them. Thank you, everyone.